In this section, I'll show you how to take a formula and solve it for another variable in the formula. So let's take a look at this. This is a popular equation of a line here, and sometimes we need to solve for either y or x. So we're going to solve this for y. So what I want to do is I want to isolate this 5y. So if I subtract 4x from the left hand side, and you can see I'm doing that right here, I can do that as long as I subtract 4x from the right hand side. Okay, then the 4x and the minus 4x will actually cancel, and I'll just be left with the minus 5y on the left, and I'll have the 8 minus 4x on the right. Now then, to isolate the y, I need to divide each term by -5. So notice here, if you divide this by -5, then the -5's cancel and you just get y on the left. Now I actually showed you two ways you could write this. You could divide the whole expression here, 8 minus 4x, by -5, but actually it's probably better if you'll just divide each term by -5. So let's see what we get if we do that. If we divide 8 by -5, well, a positive divided by negative is negative, so we'll get a -8/5. And then if we divide -4 by -5, that'll give us a positive 4/5. And then we also have the x. So it's probably best to write it as y equals minus 8/5 plus 4/5 x for your equation for y. Now this one is a geometry formula, kind of like volume. And so here it asks us to solve for r. So what we want to do here is, first thing I'm going to do is I'm going to get rid of this 4/3 right here. And so to get rid of the 4/3, I need to multiply this side by the reciprocal of 4/3, which is 3/4. So if I multiply the right hand side by 3/4, I must also multiply on the left by 3/4. So now if you multiply 3/4 by its reciprocal, then basically what that's going to do is that's just going to cancel this out, and 3/4 times 4/3 is just 1. So you're going to get 1 times pi r cubed here. Now over here, 3 times v is v, and then you have it over 4. So over there you just have 3v over 4, or you could write that as 3/4 times v. Alright, now I need to isolate the r cubed, because remember I'm solving for r. So let's get the pi away from here. Now since this is pi times r cubed, what I could do is I could actually divide both sides by pi. So I'm going to divide on the right hand side by pi, and then the pi's will cancel, and that'll just give me r cubed. And then over here I'll have 3v over 4 pi, because if I divide by pi over here, I get pi in the denominator. Now that's going to give me r cubed over here, and then 3v over 4 pi over here. But I can write it the other way around if I want to. So I'm going to just go ahead and write it as r cubed on the left, and the 3v over 4 pi on the right. Now the next thing I have to do, because this gives me r cubed, it doesn't give me r. So what I have to do to get r is I actually have to take the cube root of both sides. So if I take the cube root of this side and then take the cube root of this side, then I know if I take the cube root of r cubed, I just get r, and then on the right hand side I'll just have for my answer the cube root of 3v over 4 pi for my final answer. So now I've got r isolated. Okay, now the next one here, I have 4y over m plus n, and I want to solve it for y. So what I want to do first here is get rid of this denominator. I don't like having this denominator here. So let's eliminate it by multiplying this side by m plus n. So the denominator is m plus n, so if I multiply on the right by m plus n here, then I know that m plus n over m plus n is just 1, and that'll just leave me with 4y on the right. Now on the left, I also have to multiply m plus n times c. So I have c times m plus n. Now all I have to do now to isolate the y is just divide this by 4. So if I divide 4y by 4, then that's just going to give me y, and again I put it over here this time. So 4y over 4 just gives me y, because 4 over 4 here is 1. And then of course if I divide the right hand side by 4, I have to divide the left hand side by 4. So that would give me c times m plus n over 4. So your final answer would be y equals c times m plus n over 4. And you could multiply the numerator out and get cm plus cn, but that's really not necessary. So there's your final answer. Okay, now on this one, this is looks like it's some type of physics formula. So V might be volume 1 or volume 2 or something like that. So maybe volumes of gas. But what we have to do here is we want to solve for this V2 right here. So I need to get rid of I need to isolate the V2. So now what I'm going to do, again, I'm going to get rid of the denominator here. So if I multiply both sides by G, so if I multiply everything on the right by G, just multiply this expression by G, then the G's will cancel. And then since I multiplied on the right by G, I got to multiply on the left by G. So that just gives me PG. So now I just get this numerator, V1 times V2 minus V1. Now, to get rid of this V1, I can just take this right here and divide it by V1. So if I take that and divide it by V1 here, then it'll cancel the V1 in the numerator. And since I divided by V1 on the right, I must also divide by V1 on the left. So I have PG over V1. And now, let's look at what I've got left with on the right. Since the V1's canceled, then I just have V2 minus V1 on the right. Now we're getting close. Now remember, what I want to solve for is V2. So all I have to do is get rid of this minus V1. And there's an easy way to do that, just to add V1 to minus V1, and that'll cancel it. But if I add V1 on the right, I have to add V1 on the left. So I get PG over V1 plus V1. And then over here, when I added the V1 over here, it canceled. So now I've got V2 isolated, and so V2 equals PG over V1 plus V1. And so there's your answer for V2. Okay, the next lecture is going to be over complex numbers.